Today is our last day with radical functions, and what we're going to do is we're going to solve radical functions and work with some rational exponents. So what a radical equation is, it's an equation that has a radical in it. So it could be any type of radical, a square root, a cube root like we see right here, the third root, fourth root. Anything that has a radical is called a radical equation. Now, to solve radical equations, at some point we're going to need to raise each side to a power. To undo a third root, we would raise each side to the third power. Just like when we had x squared equals 9, and we would square root both sides, because that would cancel out the x to the second power. It's the same thing in reverse here, where if we have the square root of 9, the square root of x equals 9, we would have to square both sides to get rid of the square root. When we do that, though, we have a chance to create what are called extraneous solutions. And we've talked about extraneous solutions before with rational functions, rational equations, where we have to plug our values back in to see if we get a 0 in the denominator. Or with absolute value equations, we got to plug our solutions back in to see if the statement or the equation is still true. So we need to plug those answers back in to see if we have any extraneous solutions. The first step of solving radical equations is to isolate the radical on one side of the equation. That just means get the square root or the cube root, fourth root, get that radical all by itself. Then we're going to raise each side of the equation to the same power, like I was saying, to get rid of the radical. And then we're going to solve the polynomial equation using techniques that we know. Chances are it'll be either a linear or a quadratic, and we have those tools to solve those equations. And then we're going to check our solutions. Now, when we check our solutions, we definitely want to do that for square root equations, but when it comes to cube root equations, you don't necessarily always need to check your answers, but it's just a good idea, a good practice to just check your answers regardless, because what that could also tell you is it could also tell you that you made a mathematical error. You plug in x and you get something that doesn't work out, then you see that you've done something wrong and you can go check that out. So example 1 here, what we're going to do, we already have the radical by itself. So we're going to square both sides. And when we square both sides, we cancel out the square root. We get 5x minus 9 equals 121. We're going to add 9 to both sides. We get 5x equals 130. Divide both sides by 5, x equals 26. And then we can check that. We check that in the original. So the square root of 5 times 26 minus 9 equals 11. 5 times 26, we can type all that into your calculator. So the square root of 5 times 26 minus 9, we want to get 11, and we do. 11 equals 11, that works out, so 26 is our solution. Example number 2, the radical is not by itself. We have to add 9 to both sides. So we get the third root of x is equal to 8. We're going to raise each side of the third power. So we get x equals 512. And again, you can check this, but since it's a cube root, you don't necessarily have to. If you're unsure of whether you should check your solutions or not, just do it. Third root. So the third root of 512 is 8 minus 9 equals negative 1. That is true. So that will be your answer there. Now on the next page, we have this 2 in front of this cube root function. So we need to divide by 2 first. So we get the third root of x minus 3 equals 2. Then we can raise each side to the third power to cancel out the third root. That's going to give us x minus 3 equals 8. And then we add 3 to both sides. X is equal to 11. Again, you could check this, but since it's a cube root, we don't have to. So that's our answer. This problem here, there's 2 ways you could do it. You could solve this. You could square both sides and then add, subtract 9 from both sides. Or what we can do is look at that and say, hey, this is the square root of something equals negative 8. Is it possible to have the square root of a number or square root of anything equal negative 8 or any negative value? Because when we were graphing square root functions, we had a domain of range of x is greater than or equal to 0. Right here, we're saying that I could have a possible range of, or y value of negative 8. Well, that's outside of that range. So there's no solution since the square root of x plus 9 can't be a negative number. No matter what number I plug in for x, because that's what we're trying to do. We're trying to find a value of x that we can plug in, and we add 9 to it, then take the square root to get a negative value. There's no number that does that. So anytime you have a square root by itself equal to a negative number, there's no solution. You don't need to show any work. However, be careful. If this was the square root of x plus 9 on the outside, let's do x minus 9 equals negative 8. Once we get the square root by itself, by adding 9 to both sides, we get the square root of x equals 1. So don't just automatically think that if we have a square root equaling a negative number, that there's no solution. You have to get that square root by itself first. So that's why in this problem here, the square root's already by itself. It equals a negative number. There's no solution. This does not work for cube roots because you can take the cube root of a negative number and you can get a negative result from taking the cube root. If that just confused you and made it messed up for you, just solve this like we would normally. Square both sides, get x by itself, and then you'll see when you plug it back in, the value of x doesn't work. Now down here, we need to square both sides to get rid of the square root. When we square the left side, that is going to be x minus 2 times x minus 2, not just x squared minus 4. You have to multiply this out. So when we FOIL this, we get x squared minus 4x. I guess we can minus 2x plus 4 equals x plus 10. All right, let's combine like terms. X squared minus 4x plus 4 equals x plus 10. Minus x minus 10 minus 10. So we get x squared minus 5x minus 6 equals 0. Now we can factor this, because this is a quadratic equation, and one of our tools for solving quadratics is factoring. So we have x minus 6 and x plus 1 equals 0. So our solutions are x equals 6 and x equals negative 1. Now we need to plug those back into the original, all the way up here. So we have x equals 6. 6 minus 2 equals the square root of 6 plus 10. 6 minus 2 is 4. And then we get the square root of 16. 4 equals 4. That works. So x equals 6 is a solution. Now we're going to try x equals negative 1. So negative 1 minus 2 equals the square root of negative 1 plus 10. Negative 1 minus 2 is negative 3. The square root of negative 1 plus 10 is 9. Negative 3 equals the square root of 9 is positive 3. That is not true. Negative 3 does not equal 3. So nope, this is not a solution. It doesn't work. We only have x equals 6. So the key here is once we multiplied everything out in this step, we needed to make everything equal to 0, which we did down here in this green part. So now let's look at the next problem. And I want you to try this one on your own. If you get stuck, just refer back to this problem. It's the same idea. So go ahead, try this for a minute, and once you're done, unpause it. All right, so you can see what we have here. Go ahead and check your work against mine. You'll see that x equals 7 and x equals 10 were my original solutions. But once I checked them, x equals 7 did not work. So that means that is an extraneous solution. X equals 10 is the only one that works. All right, the word problem here. If an 8-foot ladder is leaned against the wall, the height of the ladder along the wall is given by that equation, where x is the distance along the floor from the base of the ladder to the wall. Estimate the distance that the ladder should be placed from the wall in order for the ladder to be 7 feet off the floor. So let's draw a picture of what this looks like. We have an 8-foot ladder that's leaning up against, and what we have here is the height of 64 minus x squared, where x is the distance along the floor from the base of the ladder to the wall. Estimate the distance that the ladder should be placed from the wall in order for the ladder to reach 7 feet off the floor. So we want this distance to be 7. We want these two things to be equal because this x will tell us this distance right here. You know, how far does it have to be horizontally for this vertical distance to be 7? Now, I know you might be thinking you could use Pythagorean theorem, a squared plus b squared equals c squared, and that would work too. This is just another way of doing it. So square root of 64 minus x squared equals 7. Square both sides. Okay, so then we get 64 minus x squared equals 49. If we subtract 64 from both sides, we get negative x squared equals negative 15. And if we divide both sides or multiply both sides by negative 1, we get x squared equals positive 15. And then square root both sides, x is equal to, if we use our calculators, 3.87 feet. Now you may say, well, what about plus or minus? Because this is a word problem, we don't need to worry about plus or minuses. The last part here, rational exponents. We already dealt with rational exponents. We said, okay, what would we do with 3 to the 2/5 power? What will that look like? So we're going to have equations that involve those now. So when you have an equation that contains a variable, so x, with a rational exponent, you can solve the equation using some of the procedures we just used. In most cases, we want to isolate the power and then raise each side of the equation to the reciprocal. Now, reciprocal means you're going to flip the fraction. And then we can check for extraneous solutions as well. So what does that look like? So example number 5, we want to first get that x by itself. We got to divide by 7 first. So that gives us x to the 3/5 power equals 8. What we need to do now is we're going to raise each side to the 5/3 power. The reason why we do that is because remember, when we multiply, or if we raise a power to a power, we multiply the powers. And I'm just going to show you real quick what that looks like. You don't need to do this. We won't do this for every problem. So if we multiply the exponents, we have 3/5 times 5/3 equals 8 to the 5/3 power. Remember, when we multiply fractions, we multiply straight across. So this is really going to be x to the 15/15 power. Well, 15/15 is 1. So x equals, we can type in 8 raised to the 5/3 power, and we get 32. So this stuff right here, this middle stuff, is just showing you that we could instead go from this, let me use a different color, go from this to that right away. It makes life a lot easier. Now we can check our answer. 7 times 32 raised to the 3/5 power. Does that equal 56? Calculator. 7 times 32. Whoops, forgot the parenthesis. Raised to the 3/5 power. We get 56. It checks out. So this is our complete answer. So in this problem here, we're going to raise each side to the 3/2 power. Now, the thing that you need to realize is when we raise something to, an even root, we have to worry about plus or minus. Well, how do you know if that happens? Remember, the denominator tells you what root you're taking. So if we raise something to the 3/2 power, that means we need to have plus or minus in our answer. Here, we raised each side to the 5/3 power, and 3 was odd, so we didn't need to worry about that. But because we are raising something to a power that has an even root, we need to worry about plus or minus. So these cancel, so we're left with x minus 4 equals plus or minus 16 to the 3/2 power. Is 64. So now we have x minus 4 equals negative 64, and x minus 4 equals positive 64. X equals, adding 4 to both sides, x equals negative 60. Add 4, x equals 68. So then we're going to check our solution in the original problem. Negative 60 minus 4 to the 2/3, does that equal 16? And 68 minus 4 to the 2/3, does that equal 16? So in our calculator, parentheses, negative 60 minus 4, close parentheses, raised to the 2/3 power, does equal 16. And then I'll try the other one. 68 minus 4, parentheses closed, raised to the 2/3 power, and we get 16. So for both of these, we get 16 equals 16. which is a true statement. So both of these are viable solutions. All right, so then this problem, we're going to add 3 to both sides to get the rational exponent part by itself. Now, we're going to have to raise each side to the second power. We're not going to have to worry about plus or minus because raising something to the second power isn't a root. It's not like 1 over 2, which would be the square root. This is just squaring both sides. So then this will leave us with 1/3 x minus 11 equals 25. And then we're going to add 11 to both sides. 1/3 x equals 36. And then we multiply both sides by 3. X equals 108. Now, because we are having a 1/2 power, which is the same thing as a square root, we should check that answer. So 1/3 times 108 minus 11 raised to the 1/2 power minus 3, does that equal 2? So parentheses 1 divided by 3 times 108 minus 11 raised to the 1/2 power minus 3, and we get 2. So 2 equals 2. That checks out, so 108 is our solution. I want you to try this one on your own. So go ahead, pause the video, and then once you're done, unpause it and see, compare your work to my work. All right, so you can see my work over here. I got x equals -4, and when I plug that in, I got 29 equals 29. So this solution worked. So that's what it goes into solving equations with rational exponents. So I hope that this video made a little bit of sense for you. If you need to rewatch it, go ahead and rewatch it because it can be a confusing concept. So thanks for watching. Make sure to smash that like button and subscribe.